Okay, hi, I'm Ada. I'll be a sophomore next school year, and I'm majoring in biology and minoring in chemistry. I really want to be a chemistry learning assistant because I feel like the help and compassion that the LA showed me in the chem classes that I took at UNC was invaluable, and I would love to give the same help and compassion back to others. I know I can be a reliable LA because I'm very passionate about learning and can teach others through confusion when they may seem anxious. Additionally, I have a strong understanding of chemistry. I received an A minus in Chem 101 and am doing well in Chem 102 currently. This is because instead of just memorizing, I'm able to make connections through the concepts, which tremendously helps me understand the reasoning behind how laws and equations work. I do this through making a large study guide with just the themes of each topic in a unit. This way, I can easily see how they relate to each other, and I would be more than happy to show these learning strategies to others and show them examples of the study guides that I used on each of my tests, for each of my tests.
So, I have a question.
Okay.
What exactly is the bond order of helium-2 2+?
I'd be more than happy to show you.
Thank you so much.
Of course. So, for bond order for helium, whenever I do a problem, I like to use the codes method. It really helps me to stay organized and make sure I'm not forgetting anything when solving a problem. So first, we're going to collect and organize. So when solving for bond order, we're going to be using the molecular orbital theory, and for bond order, it's the bonding electrons minus the antibonding electrons divided by 2. So that's our collect and organize. And next we're going to move on to the analysis. So let's take a deep dive into what helium-2 2+ actually is. So it's going to be made up of helium plus and another helium plus. So because there's like a plus sign, it means we're going to be taking away an electron. So instead of 2 electrons, each of them is going to have 1 electron. So now we're ready to solve the problem. So we're going to start with our MO diagram. So on this half is going to be for one of the helium pluses, and on this half is going to be designated for the other one, and in the middle is going to be the combination of the 2. So if we're going back to the analysis, we have the 1 electron on each, and this is going to be shown like this. And then when combining them, we're going to remember the Avpu law, which is starting on the lower orbital, and the Hund's law, which is making the most paired of the electrons. And remembering that when putting electrons together, the spins are going to be opposite. So now we see that there are 2 electrons in He2 2+. So then when relating that to bond order, we're going to start with the bonding electrons minus the antibonding electrons. So on our molecular orbital structure, because this one does not have the antibonding star, we know this is going to be the bonding electrons. And this one would be the antibonding electrons. So we'll do 2, because there's 2 electrons here, minus 0, because there's none here, and then divided by 2, meaning that the bond order is equal to 1. And now, since we have the bond order, we're going to think about if this makes sense. A bond order would make sense because it shows that helium-2 2+ is stable. If the bond order had instead been 0 or negative, it would show that the molecule was unstable and wouldn't exist. But we know helium-2 2+ does exist, so the bond order of 1 makes sense.
Oh, okay, that makes a lot more sense.
Do you have any questions?
No, that was great. Thank you so much.
Of course.